Okay, so I'm going to do two examples for arc length. The first one says find the arc length. And it gives you that the central angle, or theta, is 60 degrees. And the radius is 4 millimeters. Our formula for arc length is S equals R theta. So we can write in there S equals R, or 4 for R. But theta cannot be in degrees, it has to be in radians. So we have to change it into radians first. So we take 60, and we multiply that by pi over 180. The way I remember this is, for radians, I usually want a pi on the top. So, and I want these two to cancel, or reduce. So it's always by pi over 180. So I get, then 60 goes into 180 3 times, so pi over 3. So I multiply this by 4 over 3. And 4 by pi over 3. And that gives me 4 pi over 3. And that's going to be millimeters, because this is millimeters. And I can put that in my calculator. And that's 4.2 approximately. So you can leave it as 4 pi over 3 millimeters, or you can write it as 4.2 millimeters. That's the first one. The second one is a word problem. And it says, a space shuttle 200 miles above the Earth is orbiting the Earth once every 6 hours. How far does the shuttle travel in 1 hour? And it says, assume the radius of the Earth is 4,000 miles. Give your answer at both an exact value and an approximation to 3 sig figs. Okay? So then it gives you a drawing here that I'm redrawing. The middle circle is the Earth, and the radius of the Earth is 4,000 miles. And then the outer circle calculates the orbit. From the Earth to the outer orbit is 200 miles. Okay? And they want to know, if it takes 6 hours to orbit the whole Earth, how long does it take to orbit, or how far is it going 1 hour? So 1 hour would be this arc length here. So again, we're going to use S equals R theta. So we have S equals, and then the radius is, now we're talking about the big circle. So it's 4,000, the part of the Earth, plus 200, which is the part to the outside of the orbit. So that's 4,200. Multiply by the angle. So the angle, we have to think about this a little bit. If it takes 6 hours to go all the way around, we want to know how much is the angle for 1 hour. So one orbit is one circle, and we're talking about radians, so we want to use the measurement in radians. So a circle in radians is 2 pi. So we say 2 pi. We don't want the whole circle though, we only want part of it, and we want a sixth of it because it would take 6 hours to go around the whole way, and we only want 1/6 of that. So we can divide this whole thing by 6, and that would give us 1/6 of it. 2 6 reduces to 1/3, so that's pi over 3. So our angle is pi over 3, so we can put in pi over 3 here. So S would be 4,200 pi divided by 3, or, so this is the, and it was in miles squared. This is the exact value. And then if we did the one for 3 sig figs, we'd say 4,200 pi divided by 3, that's 4,398. And I'm just going to say 0.230, and that's miles squared as well. Although I think that's how, I'm just going to go out 3 places out the decimal. That's it.